Hi everyone, so this is the pre-lab for our reactions of metals with oxygen experiment. And you set up part two in the previous in-person lab. That's where you took the iron filings and put them in the test tube and then dunked that into a beaker of water. Now, if you were out on quarantine and didn't do that, we have some extra ones that we set up. So if you weren't here for the last in-person lab, you'll still be able to finish and do this. So there's two parts. First part, reacting magnesium with oxygen, you'll burn it in a crucible. And then part two is the iron reaction that's, I think, kind of interesting and neat because you know, it sits and reacts over, in this case, almost 3 weeks, a month. Uh, and something kind of cool happens. Anyway, so pre-lab for this, uh, the first thing I just want to stress is that we're not doing the calculations in the lab, and you're not, the TAs are there to help you do the experiment and obtain the data. But then because of the COVID pandemic and the physical distancing, we've been asked to just get the data and then leave. And that's why I have the discussion page set up for you to get questions answered. So that's the way we'll be doing it. So you shouldn't really, other than getting the experiment done, getting the data, you shouldn't really be there doing the calculations during lab. All right, so in part one, magnesium reaction with oxygen. Let me get the highlighter going here. Uh, and so at this point, we should know and be able to predict what this reaction is, what the formula of that product is. So what you have to do here is you just have to play along, right? You have to pretend like you don't know what the formula would be. And we're going to determine it. We're going to measure it. And so I'm not going to go through exactly how you do the calculations. The WebAssign lab report does kind of walk you through step by step. So get each answer as you go. I think it'll help you figure it out. But the basic idea here on the slide is the outline of what you're doing is you weigh a crucible and cover, then you weigh it with the magnesium in it, so you know the mass of the magnesium, right? And then you ignite it and react it. And then sometimes we're surprised by what happens because the way we tend to think about things burning and everything. But after you react it, you'll weigh the crucible, the cover, and the product. And take a look at those numbers. Some of you might be surprised by them, some of you not. It's fine either way. I think I kind of like it if we are surprised by it. Makes it more interesting. But when you get those numbers, think about, okay, how can you get the mass of oxygen out of those numbers? I'm not, no spoilers in this, spoiler alert. Anyway, so in the calculations then, we did calculations of empirical formulas earlier, and that's basically just a mole ratio between the magnesium and the oxygen. Now, to get it so that it can be graded consistently, whether we did it on paper with the TAs grading it or on WebAssign, we have to decide which one we're going to put in the numerator, right? And we're first calculating the experimental value that you measured, which has a little bit of experimental error in it. So not just rounding it to a whole number right away. And so you're going to calculate it at least the 3 digits, just like you would for any answer on WebAssign. And there's a note in the report about this. But then just so that everyone's doing it the same way and doesn't have it flipped, we want moles of magnesium over moles of oxygen. If it's flipped the other way, it won't work, okay? Anyway, especially with the calculations. So I want to help you. I don't want this to be super frustrating for you, right? It shouldn't be that bad. If it's taking you a long time, please post the questions to the D2L discussion page. It's linked right next to the handout on the D2L lab course, and I answer those throughout the day and every night. All right, the next one. Okay, experimental notes. So this is real serious, and we really need to pay attention to this. And it's the first experiment where we've had any safety concerns. So safety is really important. I want to stress it. You need to be wearing your safety glasses no matter what. The TAs will be instructed to enforce this, and if you're not wearing them, then you're asked to leave. But especially for this lab, it's care in handling hot objects, just like you would if you're making pizza at home in the kitchen, right? And you've got the oven at 450 degrees. Well, these crucibles and a Bunsen burner can get a lot hotter than that. So this is pizza oven hot, like at a fancy pizza place, even hotter than that. So you need to practice care in handling hot objects. That means if you happen to knock it over with the crucibles or drop it or something, no big deal. It takes very little time to do it. You just let it fall, hit the bench, hit the floor. You don't grab it, okay? Because it will give you a burn that you will not forget. So we don't want any burns, okay? We don't want any burns. Care in handling hot objects. And then open flames. So I should probably highlight all of these. It's really important if there's an open flame that we tie back. If you have long hair, that you tie it back. We have had in the past people singe their hair, and I don't want that to happen. Okay, so make sure you pay attention to that with dealing with an open flame. And then don't stare at the burning magnesium. This is more, it's like fireworks or whatever if you stare right at that burning magnesium. Anyway, so the magnesium is pre-cut. Moving on down the line here, it's hard for me to talk to you and not, point out what's on the slide. All materials, you're at individual workstations, right? That was designed so that we wouldn't be mixing and moving around the lab a lot. And then you don't really need to clean the crucible thoroughly. The lab instructions are that you heat it, you flame out the crucible in step 3, and that way, anything, it's gone from that time, and then you go on to do the actual lab. And then you do have to let these things cool down before you weigh them, right? When you weigh something on a balance, it has to be near room temperature to get an accurate mass. The most important thing with any lab is thinking about what you're doing. If you want to get good results, you've got to think about what's happening in the lab and what would lead to errors in the lab. So in this one, it's not losing any product. So not heating it too rapidly so that it comes flying out of the crucible and you get some of that ashy magnesium oxide being lost. And then waste disposal, the magnesium oxide will go in a waste container in the northwest hood. Let's see where we're at here. Okay, so I took some pictures of the setup because normally we would kind of show you this, and I know the TAs will be there to assist. Hopefully you're able to light a Bunsen burner. The way you light a Bunsen burner, I'll demo this with, in fact, this is how I would normally do it in the pre-lab too. Pretend this pen is a Bunsen burner, okay? What we don't want to have you do is turn on the gas and then fumble around with lighting the match, and then you're just adding gas. And there's not going to be a problem, but it just stinks, and it fills up the lab with gas. So what you do is you light your match, and then you turn on the gas and take the match and bring it up from the side of the Bunsen burner. If you just stick it right into the flame, it won't light. The gas will blow the match out every time. So just bring it up from the side and light it. And then if you have trouble adjusting the Bunsen burner or getting it lit, just ask one of the TAs to help you. All right, so the pictures here I'm hoping show the setup. So you want to heat this crucible really, really hot. It should be like glowing red on the bottom, that kind of heat once it's reacting. And so the hottest part of that Bunsen burner is right above that inner blue cone. And you want the Bunsen burner adjusted so that you can see that inner blue cone, just like the one the picture that I took today. Uh, and then, so you can see how the crucible sits. It also, it's like boiling potatoes. You want the lid slightly ajar so that air can get in there, or in my case, so you can, you know, the potatoes boil over and you make a huge mess on the stove. But anyway, if it's completely closed, hopefully it makes sense. Oxygen can't get in there to react. If there's no lid at all, it might react too fast and get out of the crucible, right? It just burns and kind of crawls its way out. All right, so that's the idea with the setup. And then, with this pre-lab too, let me know if you have any questions about the pre-lab, if there's something that doesn't seem clear to you before you go in to do the lab. Then part two. So I'm not saying much about part two. I think you can read the instructions. I don't want to give away what happens because I think it's kind of neat. And so last time you were in for the in-person lab, you wet the inside of a test tube, put some iron powder in there, shook it around, dumped it out, and then there's still some iron powder coating that test tube. And then you just plopped it into upside down into a beaker of water. And when you come and look at and get it during this, next in-person lab, you're going to see something interesting that happened. And from that, you should be able to measure and figure out the percent of oxygen in air, percent by volume. And so just make sure you read through that and think about what you have to measure before you pull the test tube out of the beaker of water. We have rubber bands to mark on the test tube. And anyway, let me know if you have any questions. If you need any help with any of the calculations or getting your lab report done, please post those to the discussion page on D2L. Thank you.